Hello students, today we are going to discuss colligative properties. What does it mean by colligative property? Colligative properties which will depend only on number of the solute particles, not on nature of the solute particles, is known as colligative property. Means this is a solvent. Okay, in this I have taken 1 liter water. In this I am adding NaCl. Let's say when we add NaCl, and one more example, 1 liter water I am adding BaCl2, and one more example, I am adding 1 mole NaCl, I am adding 1 mole BaCl2, I am adding, and 1 mole glucose I am adding. Okay, now here according to this our example, we have added 1 mole of NaCl, 1 mole of BaCl2, 1 mole of glucose. We feel that we are adding same quantity of solute, so that colligative properties means all properties remain same. Vapor pressure, let's say vapor pressure, how much vapor pressure has decreased in this solution, same vapor pressure has to decrease here also. Why? Because when we add solute molecules, vapor will decrease, vapor pressure will decrease, because on surface solvent molecules will decrease. We feel here also same vapor pressure should decrease, here also same vapor pressure should decrease, here also same vapor pressure should decrease. But in reality, it will not happen like that, because this property will depend on this solute, number of solute particles. When you added 1 mole of NaCl, 1 mole of Na plus and 1 mole of Cl minus will come. Means here 2 mole of ions are generated. When you add BaCl2, then it will become Ba plus 2 and 2Cl minus. Means here 3 ions has produced. In glucose, it will neither dissociate nor associate, so that only one molecule we can consider. So that's why the properties of the solution that are dependent only on total number of solute particle. Total number of solute particle, that is called a colligative property. Let's say when we are adding NaCl 1 mole, means it produces 2 mole. When we added 1 mole of BaCl2, it produces 3 mole. So in which case the vapor pressure will be decreases more? Because in case of this one, because more number of solute particles will be there. So solvent molecules will be less, so vapor pressure will be less. Next point, they are not dependent on the nature of the particle and shape, size and charge. Whether it is positive charge, negative charge, smaller size, larger size, these properties will not depend on this one. Number of solute particles, how many are there, based on that only these properties will influence. There are 4 colligative properties are there. That is relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. These all are colligative properties. So let me explain one by one in detail. So before going to start this one, what is abnormal colligative property? Let me explain abnormal colligative property. If solute gets associated or dissociated in solution, then experimental and observed and actual value of colligative property will be different from the theoretical predicted value. Here 2 words you heard, that is experimental and theoretical. What is mean by experimental and theoretical? So experimental means you have done an experiment and you extracted the data. From that extracted data, you calculated, you found the value of any elevation in boiling point or depression in freezing point. You considered from the experimental data, that is called what experimental. Theoretical means only by using formula. Okay, colligative properties 4 we discussed so far. That is relative lowering of vapor pressure, that is elevation in boiling point, depression in freezing point, and osmotic pressure. If you calculated that 4 values by using experiments, we can call them experimental. So by using theory formula, we can calculate it, we can call that as a theoretical. For electrolyte solutes, the number of particles would be different from the number of particles actually added due to dissociation or association. So this box I am going to explain. Let's say we are adding 1 mole NaCl. We are adding 1 mole NaCl. When we added 1 mole NaCl, when you added this NaCl into water, it will become Na plus and Cl minus. You added 1 mole only, but it produced 2 moles. Let's say we are adding BaCl2. You added 1 mole only BaCl2, but it will be dissociated as Ba plus 2 and 2Cl minus. So then it will be how many moles? Total 3 moles is there. So number of solute particles increase, then properties will change. Let's say in case of association, I added 100 molecules, 2 molecules will join, become 1 molecule. Means dimerization will take place. The number of molecules, solute molecules will become 50. Number of solute molecules decrease means solvent molecules will increase. If the solvent molecules increase, then vapor pressure will increase, so colligative properties will change. So that is due to this abnormal behavior of the solute particle, colligative properties also will change, that are called abnormal colligative properties. See here, NaCl we added, Na plus and Cl minus. Example, on adding 1 mole of NaCl in excess, water gives 1 mole of Na plus and 1 mole of Cl minus. So 2 moles of solute will be present, like that. Abnormality in colligative property can be calculated in terms of Vanta factor. So these abnormalities in a solution will be predicted or assumed with the help of Vanta factor. Then what is Vanta factor? That we'll discuss. Vanta factor is nothing but the actual extent of dissociation association can be expressed with correction factor known as Vanta factor I. So means I is equal to observed colligative property upon calculated colligative property. Just now I told you what is observed colligative property and calculated colligative property. I is equal to, otherwise you can define like this also, moles of solute particles in solution after dissociation or association, moles of solute particles before dissociation or association. So that is called what? Vanta factor I. Here, if Vanta factor considered as I, if solute particle dissociates in a solvent, then I value will be greater than 1. If number of solute particles neither dissociate nor associates, then I value is equal to 1. If number of solute particle associates, I value less than 1. Let's say I am taking one example. A moles I am taking. So it is dissociating as A1 plus A2 plus A3 and AN like this. It is dissociating. Okay. From this 1 minus alpha moles, 1 mole is there initially, it is 0, 0. If reaction not started, this value is 0. If reaction started, that is 1 minus alpha. So this is alpha, alpha, alpha and alpha. Now total moles will become what? Total number of moles of ions, total ions. 1 minus alpha plus alpha plus alpha plus alpha. That is N alpha. It is 1 plus. If you take alpha as a common, then that is N minus 1 will come. This is number of total moles. So now in case of this one, what is Vanta factor? Formula just now we have seen I is equal to number of moles dissociated, number of moles, number of solute particle of solution after dissociation or association upon moles of solute particles before dissociation or association. See this, how many moles I have taken before dissociation? 1. After dissociation, 1 plus alpha into n minus 1. So that 1 plus alpha into n minus 1 upon what? 1 will come. Okay, I is equal to 1 plus alpha into n minus 1. This is Vanta factor in case of dissociation. Here alpha means degree of dissociation, n means number of ions. For example, I am taking NaCl. NaCl will dissociate and it will produce Na plus and Cl minus. What is I value here? So number of ions are 2, N value is 2. Let's say ionic compound, so alpha is equal to 100%. Means 100 upon 100, that is alpha value is equal to 1. I is equal to 1 plus N minus 1, that is 2 minus 1 into alpha 1. So 1 plus 1 which is equal to 2. I value is 2 in case of dissociation. Let's say BaCl2 I am taking. BaCl2 will dissociate as Ba plus 2 and 2Cl minus. That is N value is how much? 3. So this is also dissociated 100%. Then what is I value? I is equal to 1 plus 3 minus 1 into 1. That is equal to what? 3 will come. So this is about Vanta factor in case of dissociation. I hope you understood this. In case of dissociation and association, how it is varying. Now we will see in case of association how Vanta factor will vary. Now you tell me, in case of association, number of solute particles will increase or decrease or remain same. Let's say we are taking acetic acid in benzene. Acetic acid in benzene will dimerize. Dimerization means two atoms will join and they are going to form one molecule. So when two atoms are joining and it is forming one molecule, the number of solute particle will decrease, right? So now in case of this association, number of solute molecule will decrease. When number of solute molecule will decrease, colligative properties will change. Okay, I am taking n moles of A molecule. In case of association, I am taking association. In case of association, Na, and it is going to form An. Here n stands for number of atoms involved in association. If dimerization, then n is equal to 2. If trimerization, n is equal to 3, like this. So if it is 1 mole and 0, if reaction not started, this is 1 minus alpha, this is alpha by n. N means I told you already. Now total moles will become what? 1 minus alpha plus alpha by n. So then 1 plus alpha is common, then that is 1 by n minus 1 will come. So this is I. This is n number of total moles. But I is equal to what? Number of moles before dissociation or association, means 1 plus alpha into 1 by n minus 1 upon 1. So I is equal to 1 plus alpha into 1 by n minus 1. So this is one-time factor in case of association. So we have seen the value of I in case of dissociation and association. Here n stands for number of molecules involved in association. If dimerization 2, trimerization 3n value. Alpha value degree of association, this one. So this is about one-time factor. Already we discussed this one. One-time factor completed. Again we'll discuss about one-time factor later after completion of this colligative properties. In this colligative properties, first one, a relative lowering of vapor pressure. So what does it mean by relative lowering of vapor pressure? That let me explain. This is experimental experiment how to calculate RLVP, relative lowering of vapor pressure. So now we have to understand RLVP, relative lowering of vapor pressure. Tell me, this relative word when we will use, relativity means if you want to compare something with some other, that is called what? Relativity, right? Here we are taking pure solvent. Pure solvent means only solvent molecules will present, right? So in this solvent molecule, you see number of solvent molecules are vaporized more. If only solvent present, vapor molecule will increase. To the solvent, when we added solute on surface, solvent molecules will be decreased. Why? Because solute molecules also will be present. Initially, only solvent molecules are there. Now, along with solvent molecule, solute molecules also present. When number of solute molecule increases, then solvent molecules will decrease. When solvent molecule decreases, vapor pressure also decreases. So P naught is the initial pressure of the solution, solvent, and PS is the vapor pressure of the solution. So solution vapor pressure will be less. So if you are going for this one, how much vapor pressure has been changed? So how to calculate that is delta P. Delta P is equal to P naught minus PS we can take. According to Raoult law, PS is equal to what? P naught A into XA will come. P naught A into XA. So just you substitute this. Delta P is equal to P naught minus P naught into XA. P naught means here pure solvent vapor pressure. A means solvent. So delta P upon P naught is common. That is 1 minus XA will come. So delta P upon P naught is equal to XB will come. 1 minus XA means XB. Why? Because XA plus XB is equal to 1, no? Right? So XB is equal to 1 minus XA we can write. So 1 minus XA is equal to XB. This is called RLVP. This one, delta P upon P naught is called RLVP. Okay. I hope this one is clear. I will summarize once. We have taken pure solvent. Solvent molecules will be greater. When we added solutes, number of solvent molecules on surface decreases. So only solvent molecules will form vapor. So that's why vapor pressure will be decreases. The difference we are calculating like this by using Raoult law. we can get this value. You substitute delta P upon P naught is equal to mole fraction of the solute you will get. So this, how much pressure has decreased, we can calculate like this. This is called lowering of vapor pressure. So delta P by P naught we can take it as a relative lowering of vapor pressure. So mole fraction of the solute, it will be equal to mole fraction of the solute. Then you will get like this. This already I told you. So P naught upon P naught minus Ps. So this formula is like this actually. P naught minus Ps, delta P we can write like this, upon P naught is equal to mole fraction of the solute. So P naught minus Ps upon P naught is equal to number of moles of solute upon number of moles of solute plus number of moles solvent upon number of moles of solute. Here A means solvent and B means solute. B means solute. Comparing with solvent, solute molecules are very less, diluted solution. NB value is less than Na. So that we can use P naught minus Ps upon P naught is equal to NB upon what will come? Here NB upon Na will come. Here NB has neglected. So P naught minus Ps upon P naught is equal to, in place of NB what we can write? Weight of the solute upon molecular weight of the solute. And in case of Na, so Ma by AA will come. Ma by AA. So P naught minus vapor pressure of the pure solvent. Ps means vapor pressure of the solution. P naught means vapor pressure of the pure solvent. Wb means weight of the solute. Mb means molecular weight of the solute. Ma is molecular weight of the solvent. Wa is weight of the solvent. So this is called approximation formula, whatever we have taken here, approximation formula. So this will give less accurate results. To get accurate results, we are changing like this. If you take reciprocal of this one, P naught upon P naught minus Ps is equal to, this is solute molecule, this is solvent molecule. So this n get cancelled, 1 plus n by 1 n will come. So this 1 if you take this side, then it will become what? Minus 1. If you take this side, it will become minus 1. P naught minus Ps minus 1 is equal to P naught Ps will come. So it will come like this, no? P naught minus P naught and minus Ps will come. So if you simplify this, P naught minus P naught plus Ps will come. So these two get cancelled. Ps upon P naught minus Ps. So P naught, again you can change the reciprocal. P naught minus Ps upon Ps will come. In case of this one P naught and in case of this one Ps. Number of moles of the solute upon total moles. So then you can shift solute molecules neglected, then this formula same. This will not change, only this will change. So this is about RLVP. Relative lowering of vapor pressure. You can change like this. P naught minus Ps upon Ps. So if you multiply and divide with 1000, then you will get molality here. So molality into molecular weight of the solvent upon 1000. Okay. So Vanta factor, how can we introduce this Vanta factor? So from here onwards, we will continue in next video. Thank you. Have a nice day.